Alrighty, now we'll set up a backwards problem. And this is one of those ones where you have a percentage.
Right.
And you want to know what the x value is based on that percentage.
Right.
So going back to class again. Let's go back to class. We can get rid of this one. So we asked, this was the pre-me-birth one.
Right.
This was the pre-me-birth one, so days on the horizontal still. And the definition of a pre-me-birth, I think this is right, is the 5th percentile.
Right.
That was the cutoff, right? 5th percentile, P5, which means that you've got 5% area down here. So the question is, what number of days chops 5% of the area from the top 95?
Right.
Now this is a backwards problem because you know the area and you're looking for the days as opposed to knowing the days and looking for the area like a forwards problem does. But you don't have to worry about forwards or backwards because you're not using that
Right,
lingo.
right.
But you have to know what you have to put in.
Sure.
And your backwards problem on the TI is called an inverse normal. So if you go back to your F5, it's still F5 distributions. Inverse is choice 2, then you go over. Its inverse normal is the very first one.
Okay.
So you're going to select him. Okay, now notice the standard deviation and average are carried over from your last computation. All you've got to do is put in the area you need, which was 5%.
5%,
Yeah,
right.
so 0.05. Enter again. And somewhere, what is that, 230, about 240 days. That's the cutoff.
Right.
240 days is the cutoff between the shortest 5% and the highest 95% of pregnancies.
Right.
And that's it. As long as you, and now the key to remember for the backwards problems, for the inverse problems, is make sure that you always shade from the left to the right.
Right.
So this one happened to be that way because it was percentile. But if I said, what's the top 5%, you have to put in 95% to get the shade to the left.
Okay.
Cool, brother?
Yeah.
You can learn from those? Awesome. We'll upload